Okay, we're looking at a hypothesis test and confidence interval for the difference between two population means. This time, our population standard deviations are known, and we're assuming that the populations are normal. Okay, the populations are normal. We need to assume that because our sample sizes are less than 30. Remember our central limit theorem. If the populations are not normal, we need the sample sizes to be 30 or more in order to use these techniques. Since in this case, from population 1, we have a sample size of 16 with a sample mean of 20 and a population standard deviation of 2. And from population 2, we have a sample size of 9, a sample mean of 19, and a population standard deviation of 3. So we're assuming normality because the sample sizes are less than 30. We know the population standard deviations, so we're going to be using Z statistics for our hypothesis test and a Z critical value when we form a confidence interval. All right, and we wish to test the claim that the mean of population 1, the unknown mean of population 1, exceeds that of population 2, or is greater than that of population 2. So this is a one-sided test, and we're given an alpha level of 0.05. So this is one-sided, so what that does is change the form of our alternative hypothesis. Our null hypothesis for differences is still always going to be 0. The difference is 0. That the unknown population means there's no difference between the two. In this case, we are looking for evidence that the first population mean exceeds that of the second. And if that's true, if this number is larger than this number, then this difference is going to be greater than 0. Okay? So the difference between population 1 mean and population 2 mean is greater than 0 for this to be true, for the first population mean to be larger than the second. So it's a one-sided test. Our alpha level is 0.05. So that's our first step. Our second step, and we're using a Z test statistic since we know the population standard deviations. We know that test statistic takes this form. The difference between the two sample sizes, again, doesn't matter what order you put them in, but be consistent. If you were reversing this, then this would be less than. You just got to be careful about how you state your hypothesis and make sure that it is in accordance with the question being asked. So here, the difference between sample mean 1 and sample mean 2 minus the hypothesized difference. The difference between the two sample means 20 minus 19 is the numerator. I didn't put the 0 here. We don't have to. We know it's there. And we calculate this value here, the square root of the first population standard deviation squared over that first sample size, and the second population standard deviation squared over the sample size from the second population. If you calculate that number, the square root of that sum, you're going to get something close to 1.118. The numerator is the number 1. You perform this ratio, and you end up, again, 2 decimals because that's the way the table is set up. I don't want you to use your calculator for these. I want you to use the numbers in the tables. So we round that Z to 2 decimals, and we get 0.89. So how surprising is that result? What's the probability that if this is true, that if there is no difference between the two population means, what's the probability that we get a value or difference as large as 1 from those sample sizes? Well, we calculate the p-value. Probability of getting a Z larger than what we got, 0.89. So I use the complement method here. Again, remember, for greater than questions, you can use the complement method or the symmetry idea. I use the complement here. So the probability that Z is greater than this number is 1 minus the probability that it is less than that number. That way we can look this number up in the table. We look this up in our standard normal table, less than 0.89. We get this number. We subtract that from the total area under the curve, and we end up with our p-value of 0.1867. Now, that's a pretty large p-value. Again, remember what that says. That says if this is true, if the actual difference between the population means is 0 or no difference, we would get a difference this far away from 0 almost 19% of the time. So it's not that surprising. Almost 1 out of 5 times when this is true, are we going to take samples of these sizes and get a difference this large in a z statistic of that number. So our step 4, we make a conclusion. Our p-value is greater than our alpha. Our alpha was 0.05. This is much larger than 0.05. So we do not have any evidence. We do not have enough evidence to suggest anything other than what we thought going into the test. Right? P-value greater than alpha. We do not reject the null hypothesis. We do not have sufficient evidence to suggest that the mean of population 1 exceeds that of the mean of population 2. We do not have evidence to suggest that. We stay with the null hypothesis. All right, if we were to conduct a 95% confidence interval for that difference between the two population means. Well, again, we know how to do this. We have the population standard deviation, so we're going to use a z critical value. And we put the population standard deviations into our expression for the standard error of that distribution. So our center of the distribution is the difference between the two sample means, again, 1. Our z critical for 95% confidence is 1.96. We've calculated this number already to be 1.118. So there's our confidence interval. The center is 1. This is the margin of error. So 1 minus the margin of error leaves us with this number, negative 1.19. 1 plus the margin of error leaves us with 3.19. So this is a 95% confidence interval for the difference between the two unknown population means. And notice here 0 is in this interval, right? If 0 is in the interval, then you have no evidence that there's any difference at all at this confidence level. A 95% confidence level, same as an alpha level of 0.05. So if 0 is included in the interval, then at a 5% level, there's no evidence to suggest anything other than that there's no difference between the two population means. Right? So this is a hypothesis test and a confidence interval for the difference between two population means when the sigmas are known. We went through the 4 steps, just like every time we do a hypothesis test. We form a confidence interval, we look at the results, and we move on to the next problem.